Hello, this is Bryant Myers, and welcome to another episode of Debunking Flat Earth. I've got a really good one for you tonight. We're going to talk about the Foucault Pendulum, and we're going to go through and show how it gives amazing evidence that we live on a rotating sphere. And as an added bonus, we're going to look at Alan Baker and his journey to Antarctica, where he did the Foucault Pendulum experiment. And we're going to do a little debunking on the whole Antarctica thing as well, because if Antarctica exists, then the flat Earth as they describe it can't exist. So by showing that there actually is a South Pole, it pretty much debunks the flat Earth model. So anyway, that'll be some fun too. But the main purpose of the video though is to go through the Foucault Pendulum. And I have on the screen here some evidences that I consider some very good positive evidence for a spinning, rotating Earth. And in the debate, I went through these different pieces of evidence, and we went through the long-range ballistics and the Coriolis effect and the centrifugal force and a few others in past videos. Today we're going to focus on the Foucault pendulum, and then in the next couple of videos we'll get into some of the other pieces of evidence with mechanical gyroscopes, optical gyroscopes, etc. So what is a Foucault pendulum? So the experiment we're going to look at is on the South Pole, and as we'll see, the period of rotation or precession of the Foucault pendulum on the South Pole is going to be equal to a day. And what's going to happen is the plane of the pendulum is going to precess around, but very, very, very slowly. I think we've all seen these Foucault pendulums like in museums and universities. And what's different between a Foucault pendulum and a normal, say, like a grandfather clock? On a grandfather clock, the pendulum is just oscillating in one plane. But a Foucault pendulum has a gimbal that allows the pendulum to rotate freely or oscillate freely in multiple planes. And so it gives more of a degree of freedom. And in a sense, it allows the pendulum to almost be in a different reference frame from the Earth. So I want to play this short little video by Jim LaBelle at Dartmouth University. And he is in the Fairchild Tower at Dartmouth, and you can see the Foucault pendulum right next to him. And it's a very big tower, so it's a really well-constructed pendulum that can, very accurately measure this precession. And of course, from it, they could calculate that latitude and the rotational rate of the Earth. But I just love this little video, so just listen into what he has to say here.
So if you think about it, this Foucault pendulum here is a kind of rotation meter. It's a way of measuring rotations. A suitably placed Foucault pendulum can be used to detect the rotation of the Earth or the revolution of the Earth around the Sun. Or in principle, you could use a suitably oriented Foucault pendulum to measure the rotation, for example, of the solar system around the galaxies.
So I just love that little clip, and we're going to get into this in another video, but it is worth mentioning how he emphasized that we can even measure the rotational rate of the Earth around the Sun and the Sun around the galaxy, but it would, it's a little theoretical because it would take so long for the precession to be detected. So now this little whiteboard here, I don't want to get too much into the math. I just kind of wanted to show it here. Down here, the equation, you can see the bottom left, and the first term of that equation is the precession. So that is showing you the rate at which the pendulum is precessing around. The second term there is actually the quicker oscillation, which is the natural frequency of the pendulum itself. But what we're looking at in this video is we're not paying attention to this natural frequency. We're looking at the first term, which is the precession. And as I said, that's actually pretty easy to calculate. It's just either the period divided by the sine of your latitude. I mean, you could just put right in your calculator the degrees latitude and take the sine and the degrees and divide by 24 hours. You'll see how long it takes to go around. Like I said, 52 hours here in Bradenton. At the North and South Pole, it would be 24 hours. At the equator, it would basically be infinity, or meaning at the equator, there's going to be no precession because there's no Coriolis force at the equator. Theoretically, I mean, you might get a little, but it would be so ridiculously slow, it would be immeasurable. And so now what we're going to look at in this video with Alan Baker's in numbers here, and we'll get into this, is that before he went to the South Pole, he did a calculation in Sonoma with a Foucault pendulum at Sonoma State University. And the latitude, based on the latitude there, you take the sine of that latitude, you get 0.62. And then you can calculate, as you can see right here on the whiteboard, you can calculate the angular speed or the angular velocity. So it's going to be slower than the angular speed of the Earth, 4.5 times 10 to the minus 5 versus the 7.3 times 10 to the minus 5. But the period's the more visual. I think we can all kind of more relate to the period of oscillation. So it's going to be about 38 hours. And the reason I wanted to include this measurement that he did before he went to the South Pole is that Alan Baker, with his 2 experiments, did 3 things that debunk flat Earth. He showed that the Earth is a sphere because you can actually use the precession speed to calculate your latitude and confirm that that is your latitude. That is the latitude based on a sphere. So we are confirming the spherical shape of the Earth by being able to use a Foucault pendulum at our latitude, that we can actually calculate our latitude based on the precession rate. The second thing he did is that he showed or gave really good evidence that our Earth is spinning, once every 24 hours. And we'll see what's his measurements of the South Pole here in a minute. And also he confirmed that Antarctica exists. And I do want to just poke the flat Earth bear a little bit on that one because it's a sensitive subject for them. So all this sounds very convincing, right? But I was just on a live stream with Witsits, and I put some comments in. I'm trying to set up a debate with Professor Dave, and he keeps running away from it because, I could be the moderator of that debate. He doesn't want me to be the moderator, and of course, he wants everything his own way. But anyway, during this live stream, somebody asked him in his chat, so how do flat earthers respond to Foucault pendulum? So I want you to listen to this, and we're going to go through his points, and we're just going to debunk all of them really, really soundly, actually.
What's the FE rebuttal to Foucault's pendulum? For one, they're completely inconsistent. It doesn't start moving unless you move it. It's literally engineered to move based on the gimbal. And for it to actually continuously go, you have to have an electromagnetic device in museums. And it does seem to somewhat possess, but just like even Einstein himself would tell you, if the sky moved around the Earth and the Earth was stationary, there'd be a translation of motion from the outside of the sky system moving around the Earth. It would translate the motion to the inside. You'd have centrifugal and Coriolis effects, and especially within an etheric background medium. Used Einstein. Even Einstein himself says that if the Earth was stationary and the sky was moving around the Earth, that there would be a translation of motion to the Earth and it would drag the pendulum around. Albert Einstein.
So I want to save that last one for the end of this video, but let's go through the other 4 points because a lot of flat earthers will bring up these objections about the Foucault pendulum. So the first thing he says is it's completely inconsistent. Well, that's just wrong. The fact that people all around the world can calculate the precession period and calculate their latitude very accurately totally debunks that. So as an example, the gentleman physicist did a Foucault pendulum experiment with a freely moving pendulum, and he was able to calculate his latitude pretty accurately considering that he did the setup himself. And it's just really great confirmation that we can do this experiment and see that it does correlate to a spherical spinning Earth as we know it. So to say it's inconsistent is just absolutely wrong. So the second thing he says is it doesn't start moving unless you move it. Well, of course, remember Coriolis is a velocity-dependent force. So there is no Coriolis force if there's no motion. And I've seen a lot of these flat earthers, they put these images or memes of cranes, right, with big, long, hanging hooks on chains, and they think that those should be moving if there's a Coriolis force. Well, again, they don't understand how this works at all. And again, we're going to see the precession motion. Something has to be in motion there. But you need a velocity. If the velocity is 0, the Coriolis force is 0. So you're not going to get anything from a stationary pendulum or a stationary big crane like that. You got to get it in motion. The next point he says is it's literally engineered to move based on the gimbal. When I heard him say that, it was just cringeworthy. Of course it's engineered to move. That's the whole point. I mean, the gimbals are... The reason that the gimbals are engineered as they are is to allow the pendulum to move freely, in all different directions. Unlike, like I said, a grandfather clock, it just has a pivot point and it can only go back and forth. And I have a few examples of gimbals here. And it's worth noting here, you can see in the bottom left, that one of the challenges, though, to get it moving is that it'll start precessing in an elliptical orbit. And this is something that Alan Baker, as we'll see, had a problem with. So we want it to start off in just a back and forth plane because it makes it harder to calculate the precession rate and other things. So what you do is you use a little, like a match or a little fire, and you get a string, and that way it'll just start swinging freely. If you try to cut it with scissors, you're going to add an impulse that'll get it going in an ellipse. Because we do want it to just be in one plane. Even though it is precessing, the natural frequency of the pendulum stays in one plane as it's precessing around. Okay, so now this is another big objection. A lot of these flat earthers will say, well, these museum devices have magnets or electromagnetic things that somehow it's boosting the Foucault to give artificial numbers that somehow match perfectly with the latitude of the place. But the fact that we can create freely moving pendulums, which the reason I like the gentleman physicist and Alan Baker is they both use freely moving pendulums. They didn't have any boosters at all. But it's worth noting that these museum boosters, they don't add any side-to-side torque. They're carefully constructed to just sort of push the pendulum in the plane that it's going, because they don't want it to be in an elliptical orbit, so they don't want any impulses to be at right angles to the plane of oscillation. So and again, if you're just giving it a boost, that's not going to affect the precession. The precession's still going to go at the same rate. And again, you can prove this by getting a freely moving pendulum at one of these museums, because again, you can turn that off, right? And you can see that it's going to precess just at the same rate as with the booster on. So again, you can prove, or you can demonstrate, that absolutely that does not skew the result. So now let's take a look at Alan Baker's little journey here. Now, like as I mentioned, he did a couple of these amazing things. Not only did he measure in Sonoma State University the rate of precession, and he calculated the latitude there, confirmed the rotation of the Earth based on that measurement. But then talk about dedication. To me, this is a real truth seeker, going all the way to Antarctica to set up a Foucault pendulum experiment to show and demonstrate very conclusively that we are living on a rotating sphere that rotates once every 24 hours. And so here's the setup here. You can see the building over here that they kind of bunkered down in. And it took them a lot of time. They had some engineering challenges to get this going. One of the things is the Antarctic Treaty. I didn't realize this, but I guess you can't have any open fires, at least at the time that he was there. So he had to figure another way to get the pendulum moving besides a fire. They eventually figured it out. Their pendulum, they were using 33 meters of wire. So this is, a very tall structure here. The longer the wire and the greater the mass, it just helps it to keep going longer. And they were able to construct one that was able to go for about 2 hours. And they would take measurements and then they have to get it started again. But they were not using any electromagnetic booster of any kind. This is free swinging, just as the gentleman physicist was free swinging. They didn't cut it with scissors. They figured a way to do it that didn't create any torques that kept it in a plane. But once they figured that out, they were able to do the experiment a few times, and they were able to calculate the period of the Earth as 24 hours plus or minus 50 minutes. And he said that he's left the pendulum down there, so I need to kind of look it up if they've gone back and duplicated it again. And there might be another more careful experiment done at the South Pole that got better results, but this is still a very good error margin and very good evidence that we live on a rotating, spinning sphere. So before we move on, I want to read this quote to you because it really did move me when I first read it. He said, "We have demonstrated a physical phenomena confirming that we are on the axis of rotation of the Earth. Although the results matches our hypothesis and nothing new has been discovered, we have placed ourselves among the stars and standing beside Galileo in recognition of our planet as a rotating sphere, floating in the heavens. We have thus enhanced our own understanding of our place in the universe. The South Pole Foucault pendulum is still in place, and periodically one of us will go out and start it swinging and take further data to refine our findings." I mean, isn't that just beautiful? Just such a pursuit of truth. And within this whole process, he confirmed the scientific method. So let's just kind of go through, because it seems like a lot of flat earthers just don't understand the scientific method. And I'm debating a few of them on these comments and in these videos, and they seem to think that the scientific method is one rigid thing, and it's not. But let's just kind of go through the basic flow chart of a standard scientific method protocol, which is, again, there's nothing written in stone here. This is just a guideline. So at first we start with an observation. So we could first observe that the stars are moving around us in a 15 degree per hour drift. Or we could watch behind the curve and see Bob show us it's 15 degrees per hour. Or we can notice the sun is moving at 15 degrees per hour. And we might conclude, based on this observation, that we live on a rotating body that is indeed rotating at 15 degrees every hour, or once every 24 hours. So from this, we can make a prediction and create an experiment. So with the Foucault pendulum, we could go to the South Pole and we could confirm that indeed this rotation is 15 degrees per hour. And we can demonstrate that with an experiment. So as Alan Baker did, he designed the experiment, and it took a lot of trial and error, but they finally got it to where they figured it all out, and they were able to get a good measurement. They were able to get the data. They analyzed the data, and sure enough, the data matched what the prediction was, and it confirmed the hypothesis. So it's just really good evidence now, analyzing the data and confirming that we are on a rotating sphere that's rotating once every 24 hours. It's just really great validation. So now I just want to kind of poke the bear a little bit. And again, this is why I was really excited about the Alan Baker experiment, is because he actually went to the South Pole, near the South Pole. That whole setup, wasn't right on the South Pole, but it was very close. So his just being there shows that there's a South Pole. And I don't know why the flat earthers say the Antarctic Treaty doesn't allow us to go there. I mean, if they really just read the treaty, and I have looked at it, and some of the bullet points are, you can't claim land as private property, you can't do any mining operations, you can't do any nuclear testing, you can't dispose of waste. I mean, nowhere is it stated that people can't go there. And further, you can see this, there's many other things in the treaty as well. But people visit the Antarctica all the time, and there's tours that go there. I mean, if you just kind of Google it, here's the South Pole here. People are going there all the time. And for them just to deny that Antarctica exists, it's just so ridiculous. I don't know how people can buy into this nonsense. And, the whole ice wall thing, I've told this to flat earthers many times. You can see here in blue, right? The ice wall I was even trying during the first debate to Dearth and to the guys there. I'm like, listen, guys, what you call the ice wall, Antarctica has many areas around it where there's no ice wall. You just go in on land, right? And yes, there is you can see here a lot of ice wall when you go around, but there's big, long stretches of Antarctica that don't have these, they're just ice shelves, really. It's not an ice wall. They call it the ice wall. It looks like an ice wall, but it's just an ice shelf. And these ice shelves are in Russia, Greenland. They're nothing unique to Antarctica. Now, Antarctica does have some of the most impressive ice shelves on Earth, but the important point is if you went around Antarctica, you'll see a lot of areas and stretches that don't have these. So for the flat earthers to say that this ice wall goes all the way around the world is not even accurate with Antarctica as we know it. And again, there's been many expeditions that have gone all the way across Antarctica. And the ridiculous thing is if it was an ice wall, these people would have literally had to traverse from one side to the other. Now, I do want to kind of bring this up here. This is kind of funny. Now, just to show you the irony and just the silliness and the nonsense that this theory really is, and the people at the top. This is Dearth's, David Weiss's Flat Earth app. And now, before the first debate with them, I wish I had it on recording. I didn't because it was before we filmed. I was like, Dave, your Flat Earth app, there's people in Antarctica that are on your app. And he said, yes, I know. He didn't even deny it. He's like, oh yeah, we have a good communication with them. But of course, they think that it's outside of the ice wall. But I'm like, okay, well, can't you get your P900 camera out and take a picture of the dome there if you're that close? If people are in Antarctica, or that close to the ice wall, we should be getting some wonderful images, some glorious, magnificent views of this ice wall, right? But it's just so nonsensical. And I find that also ironic that on his app, he's using Google Earth. So you actually, you actually have the whole Antarctica as it is on the sphere. So his app is literally confirming the sphere. And the fact that he's got people in Antarctica on his app, it's just so funny. I mean, so I kind of want to conclude this here with a really important point that Witsits talked about in our debate, our last debate. And that has to do with, okay, how can you get this? Because you heard Witsits say, he admitted the precession, right? He's like, oh yeah, well, there's a precession, but we can, Einstein himself said that it can be dragged around. So where is he getting that from? I want to play this just one more time because it's just so important to really debunk his whole model.
Einstein himself said that if there was, in a letter he wrote to Ernst Mach in 1913, he said that if the sky was moving around the Earth, then you would have a translation of motion, and then you would have Coriolis and centrifugal effects on a stationary Earth that was central. Because if the sky was moving around the Earth, it would translate the motion. You would have centrifugal and Coriolis effects, and so it would drag the pendulum around. Now, what only thing I've ever gotten back from that is he didn't say that. Well, yeah, he did. I'll show the letter right here. But anyway, so.
Okay, so actually he did say that, but guess what? As usual, Witsits cherry picking again. It's a favorite hobby of flat earthers to do quote mining because they have no real positive evidence, so they have to resort to quotes. So this comes from a letter from Einstein to Ernst Mach, but look over here what he left out. And I'm going to show you some links. I'm going to put the links below this video so you can see yourself. He left out with a practically immeasurable small angular velocity. So that is to say, what Witsits is trying to tell us is that if you had some massive dome, it could drag the pendulum around and make it precess as we can measure. So in a sense, he's kind of admitting that precession is real. And you heard him in the first tape, right? But it's like, well, wait a minute, Witsits. Then you say that Coriolis can't deflect bullets and can't, steer planes a little bit off course where they have to self-correct. So which is it, Witsits? Is it dragging along or is it stationary where there's no Coriolis or centrifugal effects? And before we get into really debunking this, the bad science, I just want to kind of ponder, like, okay, if there is some massive shell like the dome rotating to create this frame drag, which is what it's called in general relativity, forget that the numbers are way off, as you could read by Einstein there. But look at some of the problems here. So if we know that the centrifugal force is greatest at the equator, that's this little picture of the Earth here. This is the flat Earth. So this is the ice wall, here's the pole, and here's the equator. So if this dome is rotating around here, it's a big massive dome, or even if it's ether, I mean, he starts to relate this to ether, which I don't know how that would work, but whatever, if it's swirling around here, the greatest effects are going to be here. But here's the problem. How can the centrifugal force be greatest at the equator? And we know the centrifugal force is at a minimum at the south and north pole. But they're opposite sides here. If you got this big swirling, rotating dome here, you're going to have greater effects near the dome and there's going to be the least amount here in the middle. So how can the greatest amount be right in the middle and the least amount? It just doesn't make any sense. And with the Coriolis force, it's kind of the opposite. Coriolis is greatest at the poles, and it's zero. How can it be zero on a flat plane here? If you've got this big rotating massive shell, none of it works out. And then how does this translate into an ether? So some of his recent talks that I've heard him say, he's now starting to say it's the ether that causes this. But Einstein never said it was the ether. To Ernst Mach, he said if there was a big massive shell, you could create this frame dragging, and you could drag a pendulum around. But again, at an immeasurably small velocity, angular velocity. So, and then again, how does the flat Earth, sun, and moon work into all this? If you got some big rotating massive, and then if it's a massive shell, won't gravity be going up? I mean, just riddled with contradictions. And then, of course, he just contradicts himself by saying that the pendulum's dragged around, but then he denies ballistics being deflected by Coriolis, and he denies that planes don't have to correct. just, again, kettle logic. I mean, just one contradiction after another. So it turns out the correct equation to calculate how this massive shell would have an effect is the Lens-Thirring metric, or the Lens-Thirring type of equations here. And you can see here I have in yellow the frame dragging effect can be demonstrated. And this is general relativity. So he's actually invoking general relativity, which of course totally contradicts his gravity doesn't exist thing, right? Which is why he tries to then translate it into an ether argument. It's just total nonsense. But here's the problem. Not only does he cherry pick the quote, and again, and you'll see here why this is the fatal blow, with a practically immeasurable small angular velocity. He leaves that out. And I've seen this thing on these different forums where people that kind of ascribe to Witsits' model will share this meme, but they don't include this one part. And I'm going to put a link below the video. If you actually go to the Princeton website, you can see the actual article originally translated. And you can see here the immeasurably small velocity. You can just read it and actually write in Einstein's own handwriting. You can, when you go in there, you can see the parentheses around, it's like right around here, I think. And so they're definitely cherry picking. They're purposely leaving this out to deceive people. And now, in my book on gravitation here, actually also mentions this letter. I won't. It's a big book that when you hold it, it's over 1,000 pages. If you can feel the gravity for sure when you hold the book. But here's the images directly from the book, and this is right. And they actually put Einstein's letter in this book, so they're referencing it and doing some of the calculations. And the frame dragging that you get is 5 times 10 to the minus 14th radians per second. Now, what is the angular velocity of the Earth? 7.3 times 10 to the minus 5. This is 9 orders of magnitude too small. That is a ridiculously slow. And this is why they're leaving this out. Because this is not going to match what we have on Earth. Not even close. Just no way. I mean, this is, and again, this frame dragging effect comes from relativity. But you can't use it to explain the known Coriolis forces on the Earth or the known centrifugal forces like Witsits tries to do. It's just wrong by 9 orders of magnitude. I mean, that's 1 billion times wrong. It's not even close. And again, this is also from, again, the whole paper, that whole letter is in this book. So now I just want to kind of, to further drive this nail in the coffin and just sort of kill what he has to say about this. In my video number 8 of this debunking series, I go through 6 papers that he shared, and I totally debunked the heck out of them. And one of those papers was this one by Gupta. And he's the guy that, if you watch my video, that calculated a value for G that was so far off, it was just laughable. But at the end, he was the one that referenced this gravity probe B and talked about the frame dragging effect, which is this whole effect we're talking about. And gravity probe B, even one better than the calculations in this book using the Lens-Thirring equation, did an empirical measurement of this frame dragging. And, well, I got bad news, Witsit. It was even smaller. It was 10 to the minus 15. And you can see it right here. It's 0.000011 degrees per year. And when you convert that to radians per second, it's on the order of 10 to the minus 15. So that's now 10 orders of magnitude smaller than the Earth's angular velocity. And Witsit is trying to say that this is how we can have precession. This is how their model, that the ether can drag the frame around and cause the Coriolis and centrifugal effects. And he thinks that's some big thing that no other flat earthers have seemed to figure out. And he's so smart, he's been able to figure it out. I mean, he's actually just showing his absolute ignorance of what this even means. And the fact that they have to cherry pick quotes to be able to use this. And they're just fooling a lot of people. I mean, I've heard him say this a lot lately. I mean, he's just thinking this is like such great proof that they can use their model to demonstrate how these different effects can happen on a stationary Earth. But I just demolished that. It just doesn't work by 10 orders of magnitude. And let's just, I just love playing this juxtaposition here of Witsit saying one thing and then another, and then we'll kind of wrap it up. So let's hear Witsit here just to kind of show how ridiculous what he's saying is.
Because if the sky was moving around the Earth, it would translate the motion. You would have centrifugal and Coriolis effects, and so it would drag the pendulum around. So all the evidence that you invoked actually shows that the Earth is stationary. Of course, that's why you have to assume it's stationary to fly planes, assume it's stationary to fly helicopters, to shoot ballistic missiles. Everything that we do assumes that the Earth is stationary.
So in that last little video clip, you heard Witsits first say that this ether or whatever can drag the pendulum around, but then he says everything is stationary, that with ballistics and with planes, we have to assume the Earth is stationary. So which is it, Witsit? Does somehow the ether or a massive dome shell drag the pendulum around and create a Coriolis effect on your stationary Earth? Or is it stationary and there's no effect on Coriolis with ballistics and planes? I mean, do you see the kettle logic here again? Just like with gravity, he contradicts himself in these different situations. But this is all, well, they're both pretty bad. I can't say this is worse, but it's by the orders of magnitude, it's worse, because at least with a lightning strike, you're going up by around whatever 150 fold or so. Here, you're 10 orders of magnitude off with what you're saying, with what we know as the angular velocity of the Earth. And well, that's all for today. Thanks for watching. Please do like this video and leave some comments, please. I really love your comments, guys. I'm just learning so much in the comments, and I feel like the comments on these videos are like an appendix or an addendum that just are like kind of like the extra scenes of a movie, right? We're just getting all this bonus content with the great comments. And so I really appreciate you guys, and do subscribe to my channel if you haven't already. And the next video, we're going to debunk the whole Earth as the center of the universe, and we're going to kind of continue with some of these ideas and go a little deeper. And all right, well, that's all, and have a great night.